Morning, my dear students and friends. Today we discuss about Unit 4 Biomass Energy, the subject of energy technology. Is a first class. We going the unit. We discuss about brief introduction about the biomass energy. It is a syllabus. Today we discuss biomass origin. The origin is it is not a very. It have very traditional history in the biomass origin, and then what the type of resources, and the biomass estimation. Later classes we discuss about the conversion process. There is a thermochemical conversion and biological conversion, chemical conversion. Bottom side you have the process. What is the hydrolysis, hydrogenation, solvolysis, biocrude, biodiesel, power generation, gasifier. Gasifier is nothing but a gasification process. And then what is a biomass? Integrated gasification. The integrated gasification is a power plant. It should be produce electricity through the gasification process. That's why it's called integrated gasification. Biomass energy conversion. Biomass, a power is simply carbon in the natural electricity produced from the renewable organic waste product, which would have openly fired and dumped in the landfill or just left in the forest to causes of fires. The energy from the sun is transferred and stored the plant in the form of chemical energy. It is called a photosynthesis process. When the plant cut or die, wood chip, starrow and other plant matter deliver to biomass in the plant. When the biomass is burnt, it is released in the energy in the form of heat. Biomass plant burn wood and other form of waste generates steam. It is used for the villages to generate the electric power through biomass energy conversion. The energy from the steam is directed via pipes and to run the turbine. Generally, here also we can use a turbine and other generator to produce electricity purpose. It is useful for home as well as industry. In most country, even though underdeveloping country, the biomass plant have been built in countryside is a villages to provide electricity to the local population. There are waste to energy plant that burn the straws to produce electricity and power millions of homes. And it is a countryside side. It is this type of energy conversion most preferred, and it is most suitable for that because there is more waste available in the countryside. And we go to look at the energy can also use the burning of the scrap wood and the wood chip that are left over the trees has been trimmed. It is also we can use to form the energy generation. It is a flow chart. Solar energy converted somewhat chemical energy photosynthesis process. It should be go to the animal husbandry, biofuel production, crop harvesting, industrial processing, human combustion. Should be generate the waste that is called the organic waste. Energy crops, there is also energy waste should be stored underground. There is known as anaerobic digestion. There should be generated biogas. Anaerobic digestion, the orange color, so the biogas it should be converted electric power and then natural gas application. It is a cooking and other purposes. The output H2O and CO2 again go to the plant. So it is a cycle formation. The energy should be converted many form. That's why it's called renewable energy. Biomass conversion is the direct combustion. We can use direct combustion and the thermochemical conversion. It should be classified gasification, pyrolysis. Biochemical conversion is anaerobic digestion and fermentation. Anaerobic digestion is done without oxygen. The formation of biogases without oxygen through the bacteria. Fermentation is the formation of oxygen with some amount of air or bacteria. It is a main difference between the anaerobic digestion and fermentation. Biomass origin. Historically, humans have harnessed biomass delivery energy since when the time of people beginning the banning of wood fuel. It is a first. We did not know the exact year the formation of biomass. Even in 2019, biomass is only source of fuel in domestic use in many in developing countries. Most African countries that are using biomass, one of the major source of fuel to cooking purpose. All the biomass is biologically or produced matter based on the carbon, hydrogen and oxygen. The estimated biomass production in the world approximately 100 million metric tons of carbon per year. Look at it is a half in the ocean and half of the land. The formation of carbon dioxide, it is also forming in the ocean and then forming in the land. The CO2 should be converted again to go to the plant, should be converted energy. The graph we are already discussed in the world energy scenario and Indian energy scenario. It is a world energy scenario. Look at the diagram on the global direct primary energy consumption. Coal will be start 8050 up to 2018 up to 2019. The traditional biomass is have the common level. Other alternative gases was started 1985 coal, 1907. After the 20th century, the beginning of 20th century only we can find out the coal usage. 1940 or 90 nearest to 1950 we can find out the natural gases and so renewable energy is a new type of energy, should be only formed after 2000. Nowadays many industries focusing on the renewable energy to form energy conversion by using the alternatives. Biomass generally is organic matter produced by the plant, both terrestrial, aquatic and the derivatives. There is a pass in the planet or terrestrial, and aquatic is nothing but the waste from the sea and the derivatives. The biomass can be considered as a renewable energy source because the plant life renew add to itself every year. So it's called the biomass is a renewable. Look at the energy conversion. The solar energy of converted in the photosynthesis, that should be converted biomass, and finally we got somewhat heat energy from that product. It is a sources of biomass. Industrial waste, forestry waste, agriculture waste, sewage, municipal solid waste, animal residues, all the type of waste should be considered as a biomass resources. Field and plantation mass. Agriculture grab residue, crops, stave, cane trusses and etc. should be considered as the agriculture grab residue. Edible matters from the crops, environmentally spoiled grain, pulse, fruits, nuts, spices, seed and lint. It is edible matter. It is also one type of agriculture waste. Dedicated energy crops is we can use a bamboo for the construction building, and there is a good product to use the commercial purpose. That's why it's called dedicated energy crops. Plantation derivatives, leaves, break and trunks, livestock waste from the field. Its type of waste should be considered field and plantation biomass. Urban waste biomass. It is municipal solid waste. It is happening in the city side. That is called municipal solid waste. Sea waste sludge. and kitchen and canning waste. We can use kitchen and canning waste to generate the biomass. It is possible to made at our home. It's a main advantages. Industrial biomass. Next we will go to the industrial biomass. Agricultural industries produce biomass and their waste. But any other industries, the corporate company, they never produce biomass from the waste. Oil, cake, sugar, molasses, hides and skin waste, fruits and pups, dairy waste, sawdust, wood and pulp and paper shaving, fermented microbiological mass. It is called as industrial biomass. And then forest biomass. Forest biomass generally is a log residue, and the timber, forest floor debris, animal carcasses. If we are not able to go clean the forest, so it's a forest should be produce more biomass as compared than villages or city side, civilization side. Aquatic biomass is nothing but is a waste from the sea animal and sea wastes. Sea waste. There's a example like kelp and fresh water waste. It is a water hyacinth, dead fishes, mycological blooms. It is called aquatic biomass. The element composition. What is the biomass contain? Carbon, hydrogen, oxygen, nitrogen, and sulfur. It gives the some the component and then composition of the biomass. Next we discuss about biomass estimation. The biomass estimation is a major requirement. We study about the biomass protection. There is a two type of biomass estimation we can use: allometry and allometric. Allometry is one organ is correlated to another of the plant. So certain attribute to make a plant size we can call this allometry. It is only one what can I say? Only one characteristics or measuring coefficient we can use. The formula is equal to y is equal to a suffix of a x power of super subscript of b. When y is denoted the attribute of plant, v it is called as a metabolic rate or biomass. Either which we can need we give the representation of y. Here x is the size of the plant. It is generally denoted as a diameter at the shoulder height. A and b is a coefficient. Allometric equation. Allometric equation is another and developed. Here it should be connected diameter and also height. That's why it is a more preferable. It is an accurate method to find out the biomass. It is a procedure for estimating multi-scale forest biomass. First, you can measure tree diameter and then height, and then allometric model we can develop. Sum of the all over tree. Suppose we have the 200 hectares of tree means only we can same type of tree. That same we can collected one sample in the 1 acre. After that we can ordered another 100 acres of